Hello, my name is Mr. Rogers, and welcome to the first video lecture on a unit covering magnetism. And so this first video cast here, is on the nature of magnetism. And so again, as you watch this video, kind of a nice friendly reminder, it's still early in the year, that your job here is to watch the video, take notes as you need to, stop, rewind if something confuses you, and rewatch if you need to also. So, magnetism, what is it? A little bit of history here. Magnetism is simply put is the attraction of a magnet for another object. It could be another magnet, or it could be certain types of metals we'll talk about later on. Magnetism was first discovered in Greece about 2,000 years ago in an area known as, I believe, Magnesia. And so that's where the kind of name comes from. And they call them lodestones. And they look pretty much like stones, but they can kind of attract these magnetic properties. This is where the study of magnetism came from. So what does every magnet have? Every magnet has two magnetic poles. And that's either one at either end of the magnet. And this tends to be where the force is the strongest. And so that north pole is going to point north, south pole points south. That'd be you can look at it in terms of the globe. So the basic rules for magnets, two unlike poles repel each other, and two unlike poles attract each other. So opposites attract, likes repel. Now, another kind of key point here about magnets is if you were to break a magnet, let's say you were able to smash it into pieces. Well, let's say two pieces. Now what you're going to have, before you'd have a north pole and a south pole, now you have two magnets, each one with its own north and south pole. So as many times you break that magnet down, that tinier and tinier piece will still have a north pole and a south pole. Now, one of the big things that magnets have here is a magnetic field. Now, a magnetic field you cannot see. It's invisible to the human eye. But there are ways to kind of see where it is. There's some techniques we'll do in class here also. But a magnetic field is a region around a magnet where magnetic force is exerted. That's where the force is pushing or pulling on other magnets or on certain types of metals. And really the big thing, the nuts and bolts we're talking about today too, is what causes it. What causes magnetism? Where does it come from? It really goes down to that atomic level, and it comes down to that electron. We're going to talk a lot about atoms and a lot about how electrons are involved in this here. And these moving electrons produce a magnetic field. And so if you have billions and billions of electrons spinning one direction, you get a domain of atoms all pointing the same way, north or south. And if those domains, if you get billions and billions of domains to kind of line up in the same direction generally, that's when a magnet is created, and that creates that magnetic force. Now, I'm going to be doing something a little bit different in this video that I probably won't normally do, is I'm going to direct you to a couple other videos that I found that tend to be really good visuals in there too. So we'll do a couple times here, stop you and have you go watch a video and then come back. To do that, we'll have you go to, here's going to be our first one. We're talking about magnetic field lines. And what these field lines look like, and the video will explain it a little better here too. You can think about a bar magnet here. Here's the north pole. Here's the south pole. You can see the lines going to be clustered near the poles of the magnet. And they loop around from one end to the other. Kind of some of the basics of those field lines. That's what the magnetic field looks like if we could see it. So to get a little more in depth on the magnetic field lines, what I would like you to do is go to the YouTube channel. You're already there. And under magnetism, you can see here what is the magnetic field under the magnetism playlist. I would like you to watch that one right now and come back to me in this portion of the video, and we'll move on. And I will wait as long as I need to. Alright, you're done, and we're back. So, moving back to magnetism. So now, we can understand what a magnet is. We have two poles. We're going to move on to, again, down to that atomic level, things we can't see happening with the naked eye, is the idea of the electron, what the electron is doing to create this magnetic field. So what you're going to do, we're going to talk about, I should say, is the idea of an atom. An atom makes up an element, and we have elements. We'll study the elements a lot this year. But an element is one of about 100, a little more than 100 now, basic materials that makes up all matter. That's all matter on the Earth and in the universe also. And so the smallest particle of an element is an atom. And an atom has three main parts, which we're going to look at more closely here, which we'll study a lot this year, a lot of time on the atom. So our first part is the nucleus. And the nucleus is that center of every atom. And it's going to contain two particles, two parts. It contains the protons and the neutrons. So now, inside this nucleus are the protons, that's that one particle. And they tend to be positively charged, And they have quite a bit of mass also, so they're positively charged and have mass. We'll talk more about the mass side of things in later units. Now, the other side there, other really kind of important particle here, is going to be the electron. An electron is really what causes magnetism. And these guys are very, 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 very tiny, and they're spinning around the outside of an atom, and they carry a negative charge. And we'll take a quick look at a diagram of an atom. So, the structure of an atom. And again, you really got to think of this in 3D. This model is actually kind of dated because in reality, this nucleus is very, 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 very small, much smaller than it kind of shows here. And inside there, you have your protons and you have your neutrons inside the nucleus. And then on the outside here, spinning around, circling, they're kind of here, they're kind of there, are these electrons. And you see the electrons, if they line up in a certain way, and enough of them line up, this is what creates our magnetism. So I would definitely put this sketch in your notes. This is very important to understand. Label it an atom. Here's our nucleus in the middle, these two parts, the protons and the neutrons. Then spinning around the outside in different levels, we'll call them for right now, are the electrons. Okay? Now, at this time, what I would like you to do, to have a little more understanding of how this magnetism is actually created, is again, this is one of the few times I'm going to direct you to other videos. Typically, I'll do most of the talking in visual demonstrations. But again, I feel this video does a really good job of setting up how magnetism works, and he's able to draw a little bit easier. So we're going to use his. So again, you go back to the magnetism page or playlist. And this is Physical Science 6.7b, Magnets and Magnetic Domains. So go ahead and watch that one now. It's a little bit longer. And then come back to me. All right, and you're back. So to kind of finish up here, understanding now that those domains, all those little electrons spinning in the same direction, create that magnetism in those domains. When those domains line up, that's when you get that magnetism. Most of them are going to line up to get that magnetism. So a magnetic domain, a few more vocabs here, is a region where magnetic fields of all atoms are lined up in the same direction. Those electrons are spinning in the same direction, and that creates that magnetism. So in most materials, the magnetic fields are pointing in random directions. There's no real rhyme or reason. They point left, right, up, down. But again, in a magnetic material, all or most of the domains are arranged in the same direction. And hopefully that's recapping kind of the video you just watched. So we're going to stop there for today. I try to go fairly quickly through this. I know there's a lot of videos to watch today. So we're going to stop there. Thank you for watching. We'll see you down the road.